In this question, we have a platform which is supported from the bottom. So this is the support. And we have a box of weight 10 newtons kept on the left hand side, as you can see. We need to figure out the weight of this platform if the platform is in equilibrium. And C point over here is the center of the platform. Now, since it is mentioned that the object here, platform, is in equilibrium, which means it is in linear equilibrium as well as rotational equilibrium. And remember, while solving questions of equilibrium, always follow the steps. Step number one is to draw the free body diagram of the object. Step number two, balancing the force. Step number three, balancing the torques. So starting with step number one, in order to figure out the free body diagram, it is important for us to represent forces acting on objects very clearly. And for that reason, we will be drawing different free body diagrams for each object, which means individual free body diagrams. So FBD for the box, for the platform, and for the support. Now the question is mentioned the platform is in equilibrium. So all the calculations we will do only for the free body diagram for the platform. But just to make sure that whether we are drawing the FBD for the platform right or not, it is important for us to determine the FBD for other objects. And why is that important? Because while drawing the forces, remember they have to satisfy the Newton's third law, which means forces are always in pairs. If one force is acting on one object, there will be another force acting on a different object of the same magnitude, but in the opposite direction. This is the Newton's third law. So here we go. So free body diagram of the box, platform, and support. Starting with the box. The first force acting on the box is the gravitational force, which is the weight mg acting downwards. And now, since the box is in contact with the platform, there will be a contact force, which is called the normal reaction acting upwards. Since the system is in equilibrium, we can say the forces are balanced. The normal reaction and mg will be equal to each other. Mg is the weight of the box, which is 10 newtons. So we can write N is equal to mg, which is equal to 10 newtons. So the normal reaction acting on this box is 10 newtons. Now coming to the FBD for the platform, the first force acting on the platform is the weight of the platform itself. Let's say W. Now it is this W which we are supposed to find in the question. Now what are the other forces acting on this platform? That is tricky. So look at this diagram. Since the object is kept on the platform, which means the box is pushing the platform downwards. And that downward push will be the normal reaction. And where is this normal reaction coming from? It is that same force which was acting on the box. Remember Newton's third law, forces always act in pairs. So if one normal reaction is acting on the box in the upward direction, so the other force which completes the pair, that force will be acting on the platform in the opposite direction, but it will be acting on the platform. Apart from these two forces, is there any other force still acting on the platform? Yes, there is. So if you look at this diagram, the platform is kept on a support, which means the platform is actually trying to push the support downwards. To show that in the support, let me draw N1. N1 is basically the force with which the platform is pushing the support downwards. And according to the Newton's third law, there has to be another force which completes the pair with N1. And hence, if the platform is pushing the support downwards with a force of N1, that means the support is going to push the platform up with a force whose magnitude is the same as N1. And so now this is the complete free body diagrams of the objects. So I have not really considered the weight of the support because the support is not part of the question. Because in order to get the weight of the platform, we only need to focus on the free body diagram for the platform. So this was step number one. Step number two is to balance the forces. So moving ahead, this was the platform. C is the center of the platform, and this dotted line represents the line where the support was kept. Now, drawing the forces, the weight acts from the center of mass. Then we have the normal reaction coming from the support N1 at a distance of 1 meter from C. Then we have N, which is equal to 10 newtons. This is the normal reaction coming from the box. It is at a distance of 3 meters. Now the platform is in equilibrium. So step 1 is linear equilibrium, which means net force should be equal to 0. So the total upward forces and downward forces should be equal. So we have only one upward force N1 and two downward forces N and W. And that is why the equation will be N1 will be equal to N plus W. And the value of N, which is coming from the box, is 10 Newton. So we can write the equation as 10 plus W is equal to N1. So this was step 2. Step number 3 is rotational equilibrium, which means the net torque acting on the object should be equal to 0. So we will be using the formula for torque Rf sine theta. But please be very careful. In order to find the torques, it is important for us to decide about which point are we figuring out the torque. So torques can be found about any point. So let's say C is the center. Now this is one more point through which N1 is passing, and this point through which 10 newtons is passing. So although we can find torques about any point since the platform is in equilibrium, but it will be easier for us to do the torque calculations if torque is to be found about a point through which unknown forces are being applied. So for example, if you look at this diagram, N is equal to 10. So the value is mentioned. So that is not an unknown force. The two unknown forces are N1, which is coming from the support, and then we have the W, which is the weight of the platform. So it is preferable if we can find the torques either about the C point, which is the center of the platform, or this point through which N1 is passing. Now observe this carefully. If we try to figure out the torque about the point C, then the torque of W will become zero. Because remember the logic, if the force is passing through the point, torque of that force with respect to that point will be zero. Now, if the torque of weight only becomes zero, it will be difficult for us to figure out the weight of the platform, which the question wants us to find. That is why we will select the other option. We will consider this point about which N1 is passing. So torque due to N1 will definitely be zero. So finally, we have established that we are finding the torques about the support. All right, so we'll start from the extreme left. We have N is equal to 10 newtons going downwards. So the torque due to this force, we will use the formula Rf sine theta. So the value of the force is 10 newtons. The distance of this force from this point about which torque is to be found, this distance is 3 meters. So the value of torque will be 10 into 3 into sine of the angle 90, because the force, this is the force and this is the distance, they are perpendicular to each other, as you can see. So the torque of N will be 10 into 3 into sine 90. And if we simplify this, we will get 30 as the answer. 30 Newton meters, of course. So this is only the magnitude, but the direction is also important. So if you analyze carefully, this force which is acting downwards has a tendency to rotate the platform in an anti-clockwise fashion. So the torque due to N will be anti-clockwise. Next off, we have force N1. Now that force is passing through this point. So the torque due to N1 will only be zero. And finally, we have W, the last force acting on the platform, which is the weight. The magnitude of this weight we are supposed to find. So that is W only. The distance of W from the support point is 1 meters and the angle is 90. So the torque due to W will be given by this expression 1 into W into sine 90, which is just equal to W. And what will be the direction? If you observe, the support point is the pivot here. So this force W has a tendency to rotate the platform in a clockwise fashion. So W torque will be clockwise. And now since the platform is in rotational equilibrium, the total anti-clockwise torques and clockwise torques will be equal to each other. So these two values will be equal. So we can say W is equal to 30 newtons. Hence, the weight of the platform is equal to 30 newtons. And that is how we solve questions of equilibrium. Step number one is to draw the free body diagram very clearly and carefully. Step number two is to balance the forces like we did here. And step number three is to balance the torques. Here we have a bridge which is supported on 2 points A and B. And on the bridge, we have a mass of 500 grams. So the weight of the 500 grams is of course 5 newtons. Mass of the bridge, on the other hand, is 1 kg. So the weight of the bridge is 10 newtons. So they have considered the value of G to be 10. And we need to figure out the forces on each of these two supports. Now, from this diagram, we can deduce that the bridge is in equilibrium because the bridge is completely horizontal. And now let us quickly revise how to solve equilibrium questions. Step number one is to draw the free body diagram, which the question has already done. There are four forces acting on the bridge: Fa, 5 Newton, 10 Newton, and Fb. So that is step one. Step number two is to balance the forces, and then we will balance the torques. So let's start with step two, which is balancing the forces, which is basically linear equilibrium, and hence net force acting on the object is equal to zero, which means the total forces acting in the upward direction and the downward direction needs to balance. So as you can see in this diagram, Fa and Fb are acting in the upward direction. So the total upward force will be Fa plus Fb. Similarly, the total downward force will be 5 plus 10. And the equation will become Fa plus Fb is 5 plus 10, which is 15. So this was step number two. Step number three is to balance the torques, which is rotational equilibrium. So the net torque acting on the object should be equal to 0. Now, like always, it is important for us to figure out the point about which torque is to be found. Because remember, the value of the torques will be different depending on the point about which we are finding the torque. So in this diagram, you can see there are various points about which we can find the torque. So we have the point A, we have the point B. So we have this center point about which 10 Newton is passing, and then we have this point about which 5 Newtons is passing. Now, a lot of students by instinct figure out the torques about the center. There is no problem with that. We can do that. But if we are finding the torques about the center of mass, then the torque of FA and the torque of FB about the center point will be non-zero, which is fine only, but it involves a little bit more calculation. And that's why now let's read. If we find the torques about the center, we would have two unknowns FA and FB in the torque equation. And that is why it is better to find the torque about any one of the points A or B. So let me repeat, even though we could have found the torques about the center, here we will be finding the torques about the points A or B, just in order to make the calculation simpler. So here we will be figuring out the torques of all the forces about the point A through which FA is passing. So what will be the torque due to FA? It will be just 0 because FA is passing through the point A. Next, we have this 5 Newton force. So the magnitude of F is 5 and the value of R, which is the distance between the 5 Newton force and the point A, this distance will be 20 centimeters. So it is 80 minus 60. So this distance will be 20 centimeters, which is 0.2 meters. Hence, the torque due to 5 will be 0.2 multiplied by 5 multiplied by sine 90. And if we solve this, we will get 1 Newton meter as the torque due to the 5 Newton force. But what about the direction of this torque? So if you observe, this 5 Newton force has a tendency to rotate the platform in a clockwise fashion because the pivot is at point A. Hence, the torque due to 5 Newton will be clockwise. Third force acting is 10 Newton. So the magnitude is 10. The distance of 10 Newtons from the point A, this will be half of 80, which is 40 centimeters, so 0.4. So the torque due to 10 Newton will be 0.4 multiplied by 10 multiplied by sine 90. If we solve this, we'll get 4 Newton meter. And like in the case of 5 Newton, 10 Newton also has the tendency to rotate the platform in a clockwise fashion because the pivot is at point A. So the direction of torque due to 10 Newton will be clockwise. Now the last force acting on the platform is FB, the magnitude of which we are supposed to find, and the distance of FB from the point A is 80 centimeters, which is 0.8. So torque due to FB will be 0.8 into FB into sine 90. If we simplify this, it is just 0.8 times FB. Now, the direction of this torque is extremely important. Now, FB has a tendency to rotate the platform in an anti-clockwise fashion because the pivot is at point A. So, the torque due to FB will be anti-clockwise. Now, since the bridge is in rotational equilibrium, we will equate the total clockwise torque with the total anti-clockwise torques. So here we are having two clockwise torques. So torque due to 5 and torque due to 10. That will be equal to torque due to FB. So our equation becomes torque due to 5 plus torque due to 10 will be equal to the torque due to FB, which was anti-clockwise. And now if we put all the values in this expression, 1 plus 4 is 0.8 FB. And if we simplify this, we will get the value of FB as 6.25 newtons. And how do we figure out the value of FA? We go back to the linear equilibrium equation. So FA plus FB was 15. Let us make FA as the subject. We'll get 15 minus FB. Put FB as 6.25. So eventually the value of FA will come out as 8.75 newtons.